All right, so the next video for section 6 is going to be completing the square. All right, there are actually 2 more videos that we're going to do for section 6, including this one. All right, so it's going to be completing the square. The first thing that we're going to do is just go over a quadratic expression, and we're just going to complete the square with this quadratic expression. All right, when we do completing the square, what this allows for us to do, it will allow for us to write our final answer as x plus or x minus something squared. So it gives us a way to write it as a perfect square. So we'll end up getting a trinomial square. All right, so when we have an expression like this, what we do is we take our b, our number in front of our x term, and we'll divide it by 2. All right, so 10 divided by 2 gives me 5. And then we square that number. And 5 squared is 25. All right, and then in this case, since we're keeping it on, there is no equal sign, so it's just an expression. We need to add 25 and then minus 25, all right, to their original equation, or original expression. So by adding 25 and subtracting 25, we're not actually changing the value of this expression because 25 minus 25 is 0. But what this allows for us to do is regroup this. So we can rewrite this as x squared minus 10x plus 25, and then we can subtract 25 from it. All right, so it allows for us to rewrite this expression, it allows for us to manipulate it. All right, so now we have this trinomial in this grouping that we're focusing on. All right, whenever we have a trinomial, one of the things that we can work on, or one of the things that we can look for factoring, is if it's a perfect trinomial square. So then we take our 2 terms, our x squared and our constant. We take the square root, that gives me x and 5. We multiply them 2 together, it gives me 5x, and then we double it, which will then give me 10x, which matches my middle term. So that lets me know it is a perfect trinomial square. Whenever you use completing the square, it's always going to give you a perfect trinomial square. So you don't necessarily have to check your work for that. As long as if you did it right, it will always give you a perfect trinomial square. So now this will factor out as a square. And then we know that when we take our perfect trinomial square, it's our 2 square roots, x and 5. So we write x and we write 5, and whatever sign we have in front of our linear term is a sign that we use. So this here factors out to x minus 5 squared, and then we can't forget the minus 25 at the end. All right, so in the beginning, we added 25 and we subtracted 25. That does not change our equation because we're essentially just adding 0 to it. So it's just allowing for us to regroup our problem so that we can manipulate it and so that we can factor out and get a perfect trinomial square. All right, and to walk through our steps again. Remember, this 10 is our b. We take our b, we divide it by 2, and then we square it. All right, and for now, since this is an expression and there's no equal sign, we need to add and subtract the b divided by 2 squared, so that way we don't change its value. All right, once it's an equation, as we'll do in the next example, then it changes what we need to do. All right, so the next example that we're going to go over is 3x squared minus 12x plus 6 is equal to 0. So now we have an equation. The last problem that we had was just an expression because there's no equal sign to it, so it's just an expression. Now we have an equation. All right, so for here, the first thing that we always do is look to take out our GCF. So all of these are multiples of 3, so we can take out our 3. We divide each one by 3, and we're left with x squared minus 4x plus 2 is equal to 0. All right, then we can divide each side by that 3, the GCF, so that we can get rid of it. And now we're left with x squared minus 4x plus 2 is equal to 0. Right, now, if you try to factor this, you can't. Right, this tells me that both my factor signs will be the same. They're both going to be negative. 2 does not have any factors that multiply to 2 and add up to 4, so we can't factor it. So now we're going to use completing the square to solve this. There will be another method that we'll use in the future, the quadratic formula, but now it's just going to be completing the square. So when we solve by factoring, we want to set it equal to 0. But when we're solving by completing the square, we want to take our constant and we want to move it to the other side. So since it's plus 2, we're going to minus 2. Right? Then we're left with x squared minus 4x, is equal to negative 2. All right, we're going to leave a space there. We're going to fill that in a minute. All right, now we're going to complete the square. So we take our b term, and we divide it by 2. That's 2. We square it. That gives me 4. So then I need to add 4 here. All right, but now remember, we have an equation. What we do to one side, we have to do to the other. So we need to add 4 here as well. All right, the last example that we did, there was no equal sign, so it was essentially just the same side. So in that case, we needed to make sure it zeroed out. But here, since it has an equal sign, what we do to one side, we always have to do to the other to balance our equation. All right, so then we'll have x squared minus 4x plus 4 is equal to 2. And remember, we said that the completing the square will always create a perfect trinomial square, which then allows for us to factor out as a factor square. All right, so we take the square root of x squared, that's x. We take the square root of 4, that's 2. So we know it's x and 2. This sign here is a sign that we'll use, so it's x minus 2 squared is equal to 2. So just like we did before, we can then take the square root of each side. So I'm left with x minus 2 is equal to. The square root of 2 is not a perfect square, so it's going to remain the square root of 2. But remember, this is saying some number squared is equal to 2. So it can be a positive number or a negative number. All right, and then from here, to finish this out, we will add 2 to both sides, and we're left with x is equal to 2 plus the square root of 2, or x is equal to 2 minus the square root of 2. All right, for right now, you're going to leave it in radical form, and we can't simplify it. So that would be the final answer for this question. All right, one more question that we're going to do. I'm sorry, the last question is going to be its own video. So next we're going to go over just completing the square again. So remember, we move our constant to the other side of the equation, and then we take our b, right, the number in front of our x. All right, we divide b by 2 and we square it. All right, and then from here we are going to add this to both sides. Remember, we added it to both sides. What you do to one side of your equation, you have to do to your other. And then that creates a perfect trinomial square. So it's always going to factor out as x plus or x minus something squared. And then we're going to take the square root of each side so that we can isolate our x, and then we solve for x by adding or subtracting over. All right, so these are the steps for completing the square. There's one more problem that we're going to do, but that's going to be its own video.